Welcome back to the short video lecture on chemical engineering statistics. Today, I will introduce you to a very basic concept in statistics, population versus sample. Our discussion today will be a very good foundation for all calculation methods that we will learn. The first concept is the notion of population. Take a look at the photo of a soft drink bottling plant below and imagine that you are measuring the volume of the liquid that is filled into the thousands of bottles that are produced every day. Now, the set of all the measurement that you might get is population. There are two types of population. First is physical population. Second is conceptual population. Physical population have clearly defined members. For example, the population is residents of all Republic of Indonesia. Of course, we can clearly limit that the members of the population are all people who are legally registered as residents. However many, we can identify all members of the population. On the other hand, the conceptual population has members whose identities are not clearly defined. Imagine if the population were actual filling volume of each soft drink bottle. How many points could we possibly get? If we have a measuring instrument that is sensitive enough, then we will get an infinite number of volume values. For example, 385 mils, 391 mils, 395 mils, 387 mils, and so on. Of course, as long as it is within the tolerance limit of the drink product. Now we talk about census and sampling. The census is the measurement of all members of the population without missing a single one, while sampling is the measurement or taking only part of all members of the population concerned. See the picture on the side. Here, an officer is sampling water from a river. Think about it. Could we do a census in this situation? Of course, it doesn't make any sense. Then, also imagine how a bottle of river water sample is analyzed in a laboratory to monitor the cleanliness of the river. The results of the analysis should be used to infer the condition of all parts of the river, or at least the parts of the river around the sampling point. So, with the results of the sample measurements, we have to draw conclusions about the population. In measuring members of the population, we will get a random variable, which is a quantity whose value cannot be ascertained until it is measured. For a conceptual population, because of the unlimited number of members, we can only do sampling. Because the value of a random variable cannot be ascertained before it is measured, every measurement always contains uncertainty. Quantity will result in a distribution of values. In measurement, we know the terms precision and accuracy. The meaning of accuracy is the closeness of the measurement results to the true value of the quantity being measured. The meaning of precision is the consistency of results between one repetition of measurements with the next iteration. This is an example of the uncertainty in the measurement. The calibration curve of a spectrophotometer. The x-axis represents the concentration of the analyte and the y-axis represents the measured absorbance value. The experimenter performs a replication or repetition of the experiment at each value of x. The measured data is expressed as the mean of the repeated absorbance measurements for each analyte concentration. And the range of adsorbance uncertainty, which is described as an error. So, from this graph, you get a picture of not only the correlation between X and Y, but also the uncertainty. In other words, how big is the X versus Y can vary if the measurement of the calibration curve is repeated many times. This is the brief lecture this time. Hopefully it will adequately describe the difference between population and sample. See you next time in the next lecture.